Okay, so this will likely be viewed either Wednesday or Thursday, March 25th or 6th, somewhere in that range. But this is day 9 and kind of a new topic, one that I like a lot and used in a previous job, which is compound annual growth rate. And the good thing is, we have kind of touched on some of this when we were doing percentage change with prices, sales, and discounts. So we're just kind of taking that general concept, like when you have a sales tax or a discount, and just taking it one step further. So let's look at this do now really quick. The first one says 10% of what number is 30. Now there's a couple of different ways to do it. The is over of equals percent over 100 is something we've done in the past. And so in this case, 10%, so I have my percent, 10 over 100, equivalent fraction. What number is 30? So I don't know the of, all right, it says of what number. I don't know that. Of what number is x is 30. That goes right here, 30. So we have an equivalent fraction. We can cross multiply, or maybe you could just kind of do a little quick math. 10 times what gives you 100? 10. So this should be 30 times 10. This should be 300. But let's cross multiply. So 10 times x gives me 10x equals, so again, we're taking cross multiplication, 10x, equals 3,000. Divide both sides by 10, and we're left with x equals 300. So 10% of 300 is 30, or 30 is 10% of 300. Now let's look at the second one. The cost of a t-shirt is $20.50 if Minneapolis imposes a tax of 9%. So I know a tax is like an additional charge. What is the selling price? So if you remember from a couple of units ago, we did percentages. Selling price equals my original price times 1 plus the tax, or if there's a discount, it would be 1 minus R. So here, R, in this case, 9%, we write as 0.09. So this is important to keep in mind. Percentage as a decimal. Okay, so the selling price, here we know the original price, $20.50. So $20.50 times 1 plus, again, a tax rate of 9%. We're adding another 9%. So we're going to need $20.50 times 1.09. And I'm going to get out my calculator. I would encourage you to do the same. You can hit pause if you want. 20.5 times 1.09. I get $22. If I round to the nearest cent, I get 35 cents. And this seems about right. 10% would be roughly $2. So adding another roughly $2, this makes sense from a kind of gut check standpoint. Okay. So again, we are going to do problems with compound annual growth rate, which a lot of times you'll encounter when you're dealing with investments. So there's a lot of notes here, but this is the one that I want us to think about when it comes to compound annual growth rates. We have P is the principal amount of money. This is the amount that we start with, and we'll do a couple of examples, so these might be new terms. And again, principal, when it comes to math, is the amount of money we start with, not like Principal Healy or something like that. It just means the beginning amount, your principal. A in our formula is the amount of money after a certain period of time. T is the number of years that the money was invested, and R is the annual rate of growth of an investment. Again, as a decimal, this is the one that's kind of similar to the tax or the discount or a markup, okay? Because we're talking about investment return. In this case, R for this unit will always be positive. That's not the case. Actually, I've been learning in the last few weeks that's certainly not the case. But okay, so let's think about an example. All right, if you want to write this down, you can, or you can just write the formula and you have this example here. But Mr. Diaz invests $5,000 into an investment that produces a rate of return of 6% per year. So we know R is 0.06. How much does he have after 1 year? Well, after 1 year, he has this amount. He has his initial amount, plus he has this, he gets part 6% of the 5,000. So that's $5,000 times 1.06, which would be this amount right here, $5,300. And you can check that in your calculator. Just take 5,000 times 1.06. Okay. So what do we notice about that? You could pause and maybe think about it. What I notice is that it makes sense, right? 6% is a pretty healthy return. Basically after a year, he gets this extra $300, right? He has the 5,000 that he started with, and then he gets this extra $300, which is 6% of the 5,000. Okay. So here's just another way to kind of think about that. And so we could say that instead of using this $300 to buy some new sneakers and a trendy new sport coat, because Mr. Diaz always likes to be styling, he decides to keep the money in the investment for another year. So how much does he have after 2 years? Well, if you think about where this is going, we're going to take that 5,300 and multiply it by 1.06 again, right? So here was our first year, but then we multiply it by 1.06 again. And notice that in the first year he made $300, but now it's up to $618. So now we had a change of $318. And this is probably the most important part of this whole unit, is if you can understand that in that first year it was 5,000 times 1.06. This is like year 1. But in year 2 it was the 5,300 times 1.06. And so you're taking the same kind of growth factor, the return, but you're applying it to a bigger base. And that's why in that second year he made $318, because it was off of a base of 5,300, not 5,000. That is the most important concept to understand. So if you want to hit rewind and listen to me explain it again, that's fine. The idea is that our base got bigger, our growth factor stayed the same, but off of a bigger base, we're going to make more money. Okay? And then we come up with a general formula, and that general formula is the following, and this is what you're going to want to have in your notes. The amount of an investment, A, equals our principal, what we start with, times 1 plus the investment return, all raised to the t power. So in that last example, after 2 years, what Mr. Diaz had, the amount he had was the 5,000 initial amount times 1.06 squared, because we did it for 2 years. And if you do this, what you'll find, and you can, again, do it in your calculator right now, take 5,000 times parentheses 1.06, close parentheses, to the second power, and you get 5,618. Okay, so let's look at a couple of other examples. Mr. Diaz is encouraged. He looks for another investment and decides to invest $10,000 in an investment that has an annual growth rate of 8%. He holds this investment for 30 years. What is the investment worth after 30 years? So again, our formula, the amount we have after a certain period of time, is P, principal, what we start with, times this growth factor for a certain number of periods, T, a certain number of years. Plugging in our formula here, for the numbers we have the amount is going to be 10,000, what he started with, times 1 plus, or this 8%, as a decimal is 0.08, 1 is 0.08, 30 years, holy cow, it's a long time. The power of compounding. So let's put that in. 10,000 times, parentheses, 1.08, close close parentheses. And then underneath your clear button on your calculator, there's a little caret arrow up. If you hit that, and that gets you to the exponent of 30 years. And you get 100,000, 626, we'll round to the nearest dollar, 627. So finding something that grows 8% after 30 years, this initial investment turned into basically 10 times as much. And that is the power of compounding. Okay. Now, look at this next part. Mr. Dale hears about Mr. Diaz's investment, but he waits 15 years before investing any money. Mr. Dale decides to invest $20,000 in the same investment. So he also gets 8%, but he only holds the investment for 15 years, right? He waited 15 years, so he only has 15 years left in this 30-year period. What is it worth after 15 years? Well, the amount is, his initial amount was bigger, so 20,000. The investment return was the same, 1 plus 0.08, and he only had it in for 15 years. So let's see what he got. 20,000. Encourage you to do this along with me. I'm typing it into my calculator. Times parentheses 1.08 raised to the 15 gives us 64,000. If we round to the nearest dollar, 443. I'm sorry, 63,000. I should say 63,433. Sorry about that. Let me just quickly fix that mistake. 63,443. So I want you just to take a minute here. You can hit pause and think about what's going on, about the difference between these two investment returns. Okay, if you just hit pause and you're coming back, what I notice, obviously Mr. Diaz has more after these 30 years, even though he invested less to begin with. And the reason is this 30 right here. He got to invest, he got to compound that return for 30 years, whereas Mr. Dale invested more to begin with, when he actually did, but he waited these 15 years, so he only had 15 years of compounding. All right, so this idea of compounding annual growth, the more time you have in this 30 years is going to be a more powerful effect than the 15 years for Mr. Dale. And I'm going to skip over this last one, but I would encourage you to see what you get here with Mr. Haskey, 30,000, 1.08 to the 15. So again, Mr. Haskey puts more than Mr. Dale initially, 30,000, but still only 15 years. And just look at what happens and still maybe see if he gets more than Mr. Diaz. That power of compounding is important. So I'm going to do one example. I don't want to make this video too long because you guys can see the pattern, and I think you've seen some of these problems in other classes. So we have Jenny making an initial investment of $8,000 in the stock of Electronic Arts. Some of you might recognize that name. They make video games. They produce an annual growth rate of 7%. So how much does Jenny have after 5, 10, and 20 years? So the amount is my principal, which for Jenny, she saved up and found $8,000 times 1.07, right? 7%, 1.07, all raised to the 5. Then for 10 years, it's going to be initial amount, or principal, 1.07 to the 10th power. And then lastly, we're going to have after 20 years, still that initial investment, 1.07 to the 20 power. So let's use our calculator. I'll do it. Hopefully you can do it too. 8,000 times, parentheses, 1.07 to the raised to the 5th power. I got 11,000. Again, we'll just round to the nearest dollar, 220. For the second one, after 10 years, I get 8,000